Right. So today I'll be talking about the light and heavy chains, which are used in generating antibodies. So human cells, they do not have enough DNA to separate genes for each individual antibody or molecule. So instead, there's different segments. Different segments of the DNA can be mixed and matched to form different antibodies. And so that brings us with the light and heavy chains. So with the light chains, there are two light chains in humans. There's the kappa chain, which is encoded by the immunoglobulin kappa locus, which is located on chromosome 2, and then the lambda chain, which is encoded by the immunoglobulin lambda locus, which is on chromosome 22. So when the antibodies are produced by the B lymphocytes, each express only one class of the light chain. And once it's set in, the light chain class remains fixed for life of that B lymphocyte. So only one type of light chain is present in a typical antibody. Thus, the two light chains are always identical. So each light chain is composed of two tandem immunoglobulin domains. They have one constant domain and one variable domain that is important for the binding of antigens. The approximate length for the light chain protein is from 211 to 217 amino acids. The constant region usually determines what class, either the kappa or lambda, the light chain is. So here you can see a visual representation of what the light chain looks like. Alright, so for the heavy chain is a large polypeptide subunit of the antibody. Typically, a typical antibody is composed of two immunoglobulin heavy chains and two light chains. So there are several different types of heavy chains that exist to define a class or isotope of an antibody. All heavy chains contain a series of immunoglobulin domains, which usually with only one variable domain. The variable domain is important for binding antigens and several constant domains. Production of the heavy chain is a key step in the B cell maturation. If the heavy chain is able to bind to a surrogate light chain and move to the plasma membrane, then the developing B cell can begin producing its light chain. The heavy chain doesn't always have to bind to a light chain. Pre-B lymphocytes can synthesize heavy chains in the absence of a light chain, which then will allow the heavy chain to bind to a heavy binding protein. Each heavy chain has two regions. There's the constant region, and then there's the variable region. And the constant region of a heavy chain, there is made up of gamma, alpha, and I believe it was lambda, and they have a constant region which are composed of at least three tandems. For the other two words, the other two constant regions of the heavy chain is made up of the mu and the epsilon. So for the variable region, the variable region is differs from the B cells, but it's same for all the immunoglobulins produced by the same B cells or B cell clone. The variable domain of a heavy chain is composed of a single immunoglobulin, and these domains are about 110 amino acids long. So here you can see the heavy chain. The only difference now is that there's a domain region, the main segment. So to combine them both, here's what I got. When the lymphocyte divides during maturation, its genes are rearranged and the DNA sequences are assembled by random selection of the V and J segments. So for the light chains, you can take, as you saw here, how it goes from V1, V2, V3, V4, J1, J1, J2, and J3. You can take any random selection of those to create the chain. So here, this is a site for the mature B cell. Then it goes through primary RNA transcription, and then finally it becomes an RNA, the mRNA messenger to form the chain that looks like this. While on the heavy chain, you can do the same thing. You can take any numbers, V1, V2, V3, J3, J4, D1, D2, and it has the same process. Just again, there's just a domain region. So it begins at the mature B cell DNA, the mature B cell site. It's primary mRNA transcription. Then it becomes the messenger mRNA. And now here, this is what the representation of this looks like. So when they combine, these will combine to each other tightly to create an antibody. And again, this is all done by random selection. There's no particular order of how this has to go. And at the end product will give you whatever type of antibody. This can create thousands and thousands of different antibodies. But that was what the end product will look like.